All right, welcome back. Dr. Pitcher here, and we'll move on into Chapter 4 with this first lecture from Chapter 4. And I'd like to talk about cycloalkane nomenclature and the concept of cis-trans isomerism. So as far as naming cycloalkanes is concerned, we're going to name them after the name of the ring. And then we'll simply add the prefix cyclo. For example, a 3-carbon ring would be cyclopropane. 4 carbons would be cyclobutane. 5 carbons would be cyclopentane. 6 carbons would be cyclohexane. 7 carbons would be cycloheptane. 8 carbons would be cyclooctane. 9 carbons cyclononane. 10 carbons would be cyclodecane, etc., etc. So it's just like naming the alkane, except we stick this prefix cyclo in front. Now, if we have substituents, we need to indicate which carbon these substituents are attached to. And that really only applies if we have more than one substituent. So for example, let's say we had something like this guy here. We have our cyclopropane, and then this is an ethyl group, so this would simply be ethyl cyclopropane. Now the text does mention that if you have a long carbon chain and then a small ring attached to it, you'd actually name the ring as a substituent itself. So if you had 1, 2, 3, 4, 5, 6, I don't know, something like that, and then you had a cyclopropane group here, 1, 2, 3, 4, 5, 6, 7. This would be 3 cyclopropyl heptane. All right, so if we have one substituent, we would just name it, and then the cycloalkane name. If the main chain is actually larger than the cycloalkane, we would name the main chain and then name the cycloalkane as a substituent. So this would be cyclopropyl, just like we did with alkyl substituents. So let's say we had 2 substituents. So now I've got 2 methyl groups. And I can number around in whatever order. This would be 1,1 dimethyl cyclopentane. Now we could compare that to a couple of different, and I'll actually write out my CH3s here, and I'm going to indicate, again, using wedges and dashes, some stereochemistry here. Now you might be tempted in this case, this previous case here, with the two methyl groups, to just call it dimethyl cyclopentane. Well, that would be incorrect, because there are 5 carbons on the cyclopentane ring, and any of them could have the substituent. So you need to specify 1, 1 dimethyl cyclopentane. This structure is 1,2 dimethyl cyclopentane. So I would number 1, 2, 3, 4, 5. And I want to number around the ring in the order that gives us the lowest numbers. Alright, so you may want to make a note of that. So I want to go 1, 2, 3, 4, 5 instead of 1, 2, 3, 4, 5. So it's 1,2 dimethyl cyclopentane, not 1, 5. This one happens to be what we call cis 1,2 dimethyl cyclopentane. And we can contrast that with trans 1,2 dimethyl cyclopentane. Again, 1, 2, 3, 4, 5. And cis-trans isomerism refers to the relative positions of our substituents on our ring. So in this case, I've used green to indicate the methyls. And so here's my ring. We'll see that it's not actually planar like this. We're just assuming it is. And so if we look at the plane of the ring, I'll try to hold this right there. So we've got the plane of the ring, the carbons in the ring. We can see that both methyl groups are on the same side. So here's our plane, they're on the same side. That is cis. So when the methyl groups are on the same side of the ring, that is cis. Let me draw that out maybe a little bit more. Cis-trans isomerism in cycloalkanes. So I could, for example, I'm going to draw it just a little bit differently. I could, instead of drawing it like this, with my wedges representing the two groups coming out towards us, I can look at it kind of, sort of be artistic and use sort of a foreshortened ring, and I can go ahead and draw my kind of extra flattened ring there. But I've got my CH3, and CH3, and then H. I'll just show those. So that's looking at it at the end. So these guys are sticking up. They're actually not sticking straight up like that. That's just, again, sort of stylized. This is cis. Now, if I swap the methyl and the hydrogen, again, I'm pretending my green here are methyl. Now I've got the trans isomer. So I've got one methyl group that's up or coming out towards us, and one that's going away from us or down. And then if I draw it looking at it on end here, or on the edge here, I've got one that's pointing above the plane and one pointing below the plane, and that is trans. So, you know, we talked a little bit back in the lab activity talking about IR spectroscopy. We talked just a little bit about cis and trans for alkenes. Well, cycloalkanes can have cis and trans as well, and this is what cis and trans mean. Now, that said, you will want to make sure that if you have a case where you could have cis or trans, you indicate whether it is cis or trans. So this is trans. And then if I drew something like this, well, this is ambiguous. It could be cis, it could be trans. Who knows? I don't know. So you really do need to indicate your stereochemistry. If it's drawn like this, it means that you could have any combination of cis or trans. So usually you will want to specify, you'll want to use wedges and dashes. We tend not to use these kinds of drawings, but you'll use your wedges to indicate things pointing towards us, and dashes to indicate things pointing away. So again, here's the trans 1,2-dimethylcyclopentane. All right, we'll see you guys next time. Bye now.